Good morning, everybody. If I just browse the folks in the chat, looks like a good number of you guys either know me personally or just know who I am. But my name is Matt Danner. I'm the CEO of Monolith Forensics. We are a software company that makes software for the digital forensics industry. Our commercial product is a product called Monolith, which is a digital forensics management system, or what we call operating system sometimes. So it's basically a tool to help you manage your forensics team and forensics lab, like manage work, manage cases, manage track evidence, chain of custody, evidence photos, document notes, track forensic acquisitions, and then also like export forensic case reports. So if you're in need of something like that or have any interest at all, just take a look at our website and reach out to us. We'll get you signed up for a trial and get you into a demo and see if it's something that'll work for your team. So now that we've done the obligatory sales pitch, I'll hop into today's presentation. So just a little bit about me, just a quick recap on my backgrounds. Before starting Monolith, I was a forensic expert and analyst for over a decade. I still do it on the side a little bit from time to time. Some attorneys still like to use me as a forensic expert, so I still do it a little bit, but not nearly as much. But in that time, I've picked up quite a bit of information and techniques and experience. And so part of these webinars are just me diving into some technical forensic topic and just trying to share it with other folks that may not have seen this stuff before or may not be aware of it. So today we're going to talk about something called Docker, which I don't know if many of you guys are aware of Docker or have ever seen it before or used it. It's becoming, I think, a little bit more popular in the forensic community, but it's still very much a software engineering tool and an infrastructure tool used for deploying web applications and things like that. So to get started, what I'm going to do is I'm going to share my screen with a PowerPoint, which is usually not something I like to do, but in this case, I already have a PowerPoint for this presentation because I've done this presentation a few times before. And I'm just going to share this PowerPoint. So you guys should be able to see this. I'll full screen it. Megan, can you still see my PowerPoint screen?
Yep, sure can.
Okay, great. Is it full screened for you, or are you still seeing like the PowerPoint shell?
Nope, it looks full screen for us.
Okay, excellent. So what we're going to do is run through these slides really quick so I can explain to those of you that aren't familiar with Docker, that don't know what Docker is. I'm just going to walk through the basics of what it is and how it works. If you already know what Docker is and really familiar with it, well, sorry, you're going to have to sit through a few minutes of intro about what Docker is. So basically, what Docker is, it's a new form of virtualization that was developed, I don't know, probably about a little over 10 years ago for the purposes, really the primary purpose was to aid software engineers with development. Because in web app development, you might be an engineer that's developing on a Mac, on a MacBook, but you might have a fairly complex web app with a lot of infrastructure, a lot of moving pieces, a lot of microservices. They're orchestrated together into an environment where you need to be able to develop in a dev environment that closely maps to the production environment that a web application or other applications may live in. So in order to make it easier for local developers to have a very, very close approximation to a complicated production environment, a system like Docker was developed to aid in this purpose. And so if you're familiar with virtualization platforms like VMware or VirtualBox, things like that, those are traditional virtual machine systems where you are actually hosting. If you're familiar with it, you know that those are like usually very large disk images. They're pretty slow. They're heavy. They take a lot of effort to manage. You have to have a lot of disk space. You usually have to have a large VM platform to manage it. To manage it properly. What Docker does is it significantly reduces the footprint of virtualization for very straightforward use cases. So something like, hey, if you just need like a very small incredibly slim Linux operating system to work out of to run some software or to virtualize something, you can use a Docker container for that, where you can build a very, very small Linux operating system running on Mac OS that basically only requires maybe 50 megabytes of disk space and very little memory. So it will spin up in seconds as opposed to several minutes of you orchestrating and deploying a traditional virtual machine. Um, so like this PowerPoint kind of just sort of summarizes what I just talked about. It just basically allows you to deploy these really small uh, VM virtual machine images on a system. So if you're a developer and you need to launch a development environment that has, let's say, a dozen microservices that each run in their own like little Linux distribution or whatever. Well, that's great. You can use Docker for that. You can launch 12 different instances. They each have a very small footprint. So, a laptop can easily run them because you don't need all the production environment may require, dozens of gigabytes of RAM to run. It may need, terabytes of storage space to run and lots of compute power, all this stuff. But you don't need that for a local development, just to simulate the environment for development. You just need like a small microcosm of that just to run your laptop, just so you can test your code and things like that. So in this case, we're taking that virtualization and just converting it to a system that requires a fraction of the resources. So if we take a look at, we'll pull up Docker Hub here. And if you go to Docker Hub, and let me switch my screen over so you can share this. Give me just a second. So what Docker Hub is, you can navigate to Docker Hub if you want. What Docker Hub is used for, it is basically basically a repository for Docker images. So if you're curious about the different types of Docker containers you can create and the different types of applications or platforms that you can use with Docker, just go to Docker Hub and browse the image repositories that they have. And you can see just browsing here, we've got stuff like, AI is a big thing. So all the top container images are AI related. So we've got like a LangChain container here, PyTorch, TensorFlow. Here's a standard Python image, which is great because if you want to, this is another great use case in DFIR, is if, let's say you write a really cool Python script that does some really cool forensic-y stuff, and you want to share that with the community or share that with other people on your team, but now you got this problem where you've got all these dependencies in the script that the script requires. It requires a specific version of Python, all this stuff. But what you can do is you can containerize it into a Docker image, and that Docker image will have all the dependencies and everything baked into it. So the user just has to have Docker, and then they can just run your Python script as a Docker image instead of a Python script. Because if you give them the Python script, they now have to install Python, and they have to install all the library dependencies that you have. It's a whole process. But if you use Docker instead, all they have to have is Docker, and then they just get a copy of your Docker image and run that directly. And it solves the entire dependency chain problem. You can see some other things here like Nginx, which is a web server. You've got MySQL, Postgres. So you can run a MySQL database locally using Docker. You can run Postgres locally using Docker. Instead of like doing the traditional, I'm going to install a database, an entire database system or service on my local laptop. You don't have to do that. You could just use Docker instead. It's a lot easier. You can then also launch multiple database instances if you want. So it just makes doing these things that we used to do old school a lot easier. So if you ever do forensic work and you like to use these databases for different types of customized forensic work, using Docker is a much, much better way to do this than trying to just install the MySQL or Postgres service locally. Because it's still the same thing. It still has input and output ports, and you still connect to it in the same way. It's just running inside of a Docker container as opposed to a full-blown installed service. All right, let me switch back to my PowerPoint here. Okay. All right, so here's kind of the magic behind Docker. This is how Docker actually works at its core and why it requires so much less resources than a traditional virtual machine. So if we look at the right side here, the image that represents the sort of infrastructure of a virtual machine, What you typically have is you have some kind of host infrastructure, which is like hardware, servers, or a computer or something. You have a hypervisor, which is a virtualization layer that runs on the host infrastructure. That's what allows the general virtualization. And then you have individual virtual machines. And those virtual machines encapsulate in it basically an entire virtual computer system, which means it has a virtual disk, it has virtual memory, it has an entire operating system. And when I say that, I mean it has everything in the operating system, all the way up and down to it includes a kernel, it includes all the host operating system requirements. And basically, that's why these virtual machines are so heavy. And then you run applications inside of it or multiple applications inside of it, that sort of thing. And then you have to launch each one of these with virtual memory, virtual disks, virtual compute, all that stuff. You have to launch each time with a virtual machine. On the left-hand side, the difference with containerized applications is that instead of having the sort of baked in operating system from scratch in each individual container, what Docker does is it actually just piggybacks off the host operating system. So Docker basically acts as an adapter between your host operating system and the container that needs to utilize certain functions. So what that means is that the containerized system, you can have a containerized Ubuntu, like Ubuntu server, for example, that is significantly smaller than the virtual machine, because what the container is going to do is it's going to just use your host operating system's disk or disk storage. It's going to use your host operating system's memory, and it's just going to allocate itself whatever memory that needs. It's also going to operate off of your host operating system's kernel, so it doesn't have to build out all of its own libraries and support drivers for all your hardware. That's what Docker does for you. Docker provides that layer of allowing these containers to communicate with the hardware on your host system. So what that means is that all that baggage that you get with virtual machines is now gone with containerized applications. And that's where the magic is. That's how containerized, that's why you can launch an Ubuntu server on Docker with just like a few megabytes of disk space, or with just a small amount of memory. You don't really need that much, and then the container can be started and stopped within seconds. It's very fast. It's very convenient. The downside is you just have to kind of learn the mechanics of Docker. You got to learn the syntax and the playground of how Docker works to really understand how to utilize this. But once you do that, once you get familiar with Docker and really understand how it works, and learn some command line syntax, all of a sudden this containerized system becomes extremely powerful. And I know we're talking a lot about engineering in this context, but really this is something that I don't think the forensic community is taking enough advantage of. I think some people are, but basically there's a lot of stuff you can do with these containerized systems that can really enhance your forensic workflows in terms of using it to launch and host different databases, using it to launch and host different types of scripting tools. If you look at SANS has their log to timeline system. They have it containerized as a Docker container. So you can run log to timeline or Plazo as a Docker container, as opposed to trying to install it locally with all the weird dependency problems and all that stuff. So it really solves a lot of really interesting problems that we've had in the forensic industry in the past. So let's break down kind of some of the basic terminology for Docker. And to be clear, we're talking about Docker here. Docker is just the sort of commercial application. Docker is really just a container management system. There are other systems out there that do what Docker does. Probably the most prominent one is something called Podman. It's Podman, which is a open source container management system. And it's the same concept. It's using the same concepts. It's just you can use Docker if you want, or you can use Podman. And they're just different flavors of the same container management systems. They have slightly different command line interfaces, so you have to kind of learn which one's which. But the problem is Docker is technically a commercial application, so depending on who you are and who you work for, you may run into licensing issues when trying to use it. Podman is open source, so you can use Podman instead if you want, if you don't want to worry about licensing or anything. But generally, Docker is still free to use, especially if you're using on a Linux distribution. There's just a community edition that you can use no problem. Docker Desktop on Windows and Mac OS is where things get a little weird with licensing. Okay, so we have two really basic concepts in Docker. We have a concept of images and the concept of containers. An image is basically just like it sounds. It's just basically the actual distributable version of your Docker package. So it is what you create. When you design something like, let's say you want to ship, you've got a really cool Python script that does some really interesting forensic thing, and you want to share it with other people. Well, what you do is you can take that script and package it into a Docker image that it can be shared with other people. And we're not going to go into details of how to do that, but basically what the Docker image would be with that Python script is you would start with the base Python Docker image. You would load your Python script into that base image, and then you would repackage it as a new image, and you'd call it my cool forensic script. And it would create this little image. It's probably maybe 30, 40 megabytes in size. And then you would publish that image on Docker Hub, and then someone else can download that image and then use it in their Docker system. So now this is where the next step comes in with containers. So once that other user downloads a copy of your image that you've constructed and deployed to other users, the other user, in order to use it, they have to launch that image as a container. So what a container is just a running, is the running virtual machine that is deployed using that image. So you can think of the image as sort of like the template or the blueprint, and then the container is like the actual like house, is sort of like the results of using that image to deploy something. And so the container is the actively running virtual machine instance that was built on top of that image. And sometimes if you have something like a simple Python script, that container just runs for a few seconds and then immediately dies and closes it, because all it's doing, its whole purpose is just to quickly deploy itself, run the Python script, and then kill itself off, because that's all it's doing. If you're using a Docker container to run like a web server or something, then when you start the container, it'll just start and it'll just keep running forever until you stop it, because that's the purpose. It's supposed to stay running forever to receive and handle requests. But for very simple Docker images where it's just a Python script that does a couple of things, you use Docker to run the script does its thing, and then when it finishes, the container then closes and dies off. And then you just do that over and over again with that image, and where you're constantly creating and killing off containers. Okay. So just to recap, we've got images and containers. Images is like the template, the blueprint, and containers is the instance that gets deployed based on that image, template, blueprint. So here's some examples of what kind of applications you can run with Docker or containerized systems. So here you're just saying we kind of covered some of these already. You can run an Ubuntu Linux server if you want. You can run any database you can think of, basically. We just talked about Python, so you can run any type of Python stuff you want. Also, one thing that's really interesting is you can run Elasticsearch too. So Elasticsearch has Docker images that you can download and run locally, and they have pretty good documentation on how to run it. So if you wanted to run a full elk stack on your local MacBook to do some kind of log analysis or something like that, or to ingest a ton of logs locally just to help you with analysis, you can do that. You can deploy an entire elk stack pretty simply on your MacBook or on your Windows laptop or whatever, just to utilize a large search index. You run web servers. You can do custom builds, so we say like Monolith. So we use Docker to deploy Monolith both for on-prem customers, and we use it in the cloud. So our infrastructure stack for our cloud app uses Docker to manage like all the different containers that we run that basically makes up the Monolith system. And we've already looked at Docker Hub, so we'll skip that one. Now, how can you use Docker? There's a few different ways you can do this. If you're on Windows, easiest way is you can just open up Google Chrome and Google Docker Desktop, and you can basically download Docker Desktop and install it for Windows. And so it gives you just this nice desktop client that you can use to interact with Docker. And now on Windows specifically, you want to install what's called WSL2, which is the Windows subsystem for Linux. And what that WSL is that's just the background adapter that Windows has so that you can run Linux containers. Because remember when I said that the magic of Docker is that these containers piggyback off your host system operating system kernel. In order for Linux containers like Ubuntu server to run on a Windows Docker installation, Windows has this WSL, this subsystem layer that basically provides the Linux kernel to those Linux containers. Okay, so that's why you need WSL if you're going to run. Now, you can also run Windows containers if you want, which then you don't need WSL. But if you want to run like most containers, which are Linux based, then you need that WSL2 on Windows, which is it gets installed at the same time that you install Docker Desktop. So it's not that hard. Just make sure you check that option when you're going through the setup. Docker on Mac OS is much easier. You don't need WSL because Mac OS is a Unix based system. Or flavor, it has the appropriate drivers and kernel that Linux containers need by default. So you just install Docker Desktop from Mac OS, and it works right out of the box. And then for Linux, if you're trying to install Docker on like Ubuntu, what you're seeing here is the install script. This is the method I recommend because it's the most clean, the most straightforward. It's basically you download this official install script by Docker, and then you run it, and it just installs the right version of Docker for your version of Ubuntu, and it gets it installed very quickly and easily. There's a lot of other methods to do it, but this is the one I recommend, and you can Google this. Docker has a whole page on the process for installing Docker on Linux versions, but this using the install script is the best way in my opinion. Here's some useful command line commands. So you have Docker stats, which just shows running containers, Docker compose. So we haven't talked about this, but there is a configuration system you can use with Docker called Docker compose. And that's just useful if you need to run several containers that are all orchestrated together into a specific configuration. You can create a Docker compose file that sort of defines that configuration and then use Docker compose to deploy an orchestration of containers. So if you're doing something more complicated than just a single container, you can use Docker Compose to deploy several containers at once as opposed to just one. Docker exec-ti, this is really useful because it allows you to basically open a terminal shell inside of a container. So while a container is running, especially a Linux container, like I said, it's just a virtualized Linux environment. So you can open a shell into it just like you can on if you're using Android, you can open a shell using ADB shell, right? Here, you're doing the same thing. You're just opening a shell into that running Docker container so that you can basically run commands from within that container. If you want to see a list of your running containers, you do Docker container ls. If you want to see a list of your images that you have installed on your system, Docker image. Docker container inspect. So forensics wise, Docker container inspect is really, really useful. Because if you have a running system that's running Docker and you're trying to figure out what the Docker configuration is, like how it's set up, what it's currently deployed, Docker container inspect is really, really useful because it shows you can basically get a list of running containers and then inspect each container, and it gives you a JSON output of the exact configuration of the container, including things like mount locations and configuration files and basically all the typical forensic stuff we would want to know to inspect and understand how a container is constructed and what it's doing. And then we have container logs as well. So you can output logs from a container. So all these containers have their own logging systems. And what you can do is you can run a Docker container logs with container name and then just do a pipe to some kind of log file. So if you wanted to export and preserve container logs running. So let's say we have an Nginx container that's running and you want to export things like maybe there are HTTP logs or error logs or something that it's outputting to the container. You can run this Docker container logs, Nginx container name, and then just pipe it to like a log.txt file or something, and then export that log for preservation if you want it. And if you want, I can show on this system how these commands run, but we only have 45 minutes, so I'm going to try to get through some of this. If I have some extra time at the end, I'll walk through that. So we kind of covered the basics of Docker, so let's dive into kind of some of the forensic utility here. There's two sides to Docker in terms of forensics. There's the investigation side where you run across a system that has Docker installed or has a containerized system installed. So you need to kind of think about it from a forensic perspective. What are we actually analyzing here? What are we looking for forensically? And then you have the utility purpose, which is, we can use Docker ourselves to help us do forensics. So things like, create these sort of Python scripts that are containerized, or even a series of Python scripts within a container, or we can use it for like we said, deploying an elk stack to help with analysis, or use it to deploy log to timeline, all these kinds of things that we can use it for from a utility perspective. But the thing to keep in mind is Docker containers are their own little universes. So if you run into an operating system that has Docker on it and you discover that it had 5 or 6 running containers, well, you've got a little bit of work on your hands potentially, because each one of those containers is basically like an individual examination that needs to be conducted, because they have their own artifacts, they have their own basically operating system layer. So you're going to go through the process of basically examining, each one of those containers like it's its own system that needs to be analyzed. They can also have custom logging. So if you're used to seeing traditional forensic artifacts and traditional logging, like Windows event logs, things like that, well, because of the nature of containers, the person who put the container together can have and construct customized logging systems. So you just have to be aware of, okay, does this application output any custom logging? And that's where that container inspect command comes in, because that container inspect will help you understand if there's any customized logging that's being output or something like that. Another thing to keep in mind too is, because you can do what are called volume mounts. There is a way to construct a container so that it stores files on the host file system. So what that means is, like, data associated with the container can be located both inside the container and outside the container. And again, this is where you need to think about that container inspect command, because that will tell you, that'll give you information as to, is it mounting any file system points? Is it pushing any data directly out to the file system, or is it just storing everything internally for itself? So for an examination purposes, on a Windows system, if they have Docker installed, these are kind of the sort of magic locations you need to think about. You'll see here, you basically dive into the app data folder for the user, find that local Docker, and look for this WSL. And what you're going to see is, on Windows, the way that Docker works is it actually constructs virtual hard disks. And these are virtual hard disks that are basically ext for file systems. So if you have a Windows disk image that you're looking at that has Docker installed, you can basically go look at these locations, and you're going to find these VHDX files that you can extract from the image and then reload into something like Xways to then examine that containerized system. And basically, in this case, these would be Linux boxes, like Linux-based operating system disk images. So you could export these VHDXs and then just reload them into your forensic tool of choice to do a traditional forensic examination of these files. But just be careful of the construction, because sometimes these containers can use multiple VHDXs. So just be aware of that. On a live running system, when Docker is running, there are a couple of sort of hidden paths that you can access from File Explorer. So if you want to basically view the contents of these VHDX files without necessarily turning off the system or anything, these two bottom paths here, WSL $, these are hidden UNC paths that you can type into your File Explorer window, and it will basically let you walk through these VHDXs, because what Windows is effectively doing is it's constructing these VHDX files and then mounting them virtually as hidden volumes inside of Windows. And to access those mounted volumes, you can go to these locations here, WSL $, and you'll see these sort of hidden volumes that are mounted while Docker is running. And then inside the mounted volumes, this is just the breakdown of the locations of where the images, containers, and volumes are located. So when we talked about images and containers, these are basically just files that are effectively just on the system. And these are cache locations of where this data ends up being stored. I haven't talked about volumes yet, but volumes is a third component to the system where Docker uses a concept of volumes to store data externally to the container. So in order to persist data, so that if the container gets destroyed, the volume, some of the data may stick around. Docker has this concept of volumes, where it can create volumes which are just allocated disk space that a container can use to store data based on its operations and things that it's doing. On Linux, specifically Ubuntu, these are the locations you're going to be looking for. You're looking for that var lib docker folder. And same as Windows, you're going to have this overlay containers and volumes location, which just maps to images, containers, and volumes. So you can use that to examine where data is located for Docker's installations on Linux. So we have or towards the end here, we have a live Docker review. So what I'm going to do really quick, I'm going to stop my share. I'm going to open up a terminal here on my MacBook because I've got Docker running locally on my MacBook right now. And I'm just going to walk through a couple of Docker commands so that you guys can see it. Zoom in here on my terminal. And let me share. Okay, here we go. All right, hopefully you guys can see this. Hopefully I've zoomed in enough. I'll try to zoom in a little bit more just so you guys can see it. Okay, so I'm on my MacBook. I do have Docker running, so I can run some Docker commands. And I'm going to just run Docker container ls. And this is going to give me a list of Docker commands. Enter my password here. And so what you're seeing here is you're just seeing I've got some random containers running on my system right now. And this Docker container list command is just listing out all the running containers. So these are containers that are currently running, that are built off of, and you can see this is basically a table. There's a list, there's an image column here that tells you the actual Docker image that these containers are based on. So I've got a Redis container here, which is a key value memory cache. I've got a Postgres database running. I've got a MinIO server. I've got a MySQL database running here. And then I've got like a MIS database here as well. So I've got some databases running currently and a key value store running. So I can also, so that's just the list command. I can also do, say, sudo docker image ls. So I'm also pulling up a list of images as well. So these are all the images that are currently stored on my system that I can create containers from. These are images that either I've created or I've downloaded from Docker Hub. I can also do something like I can do Docker. And so let me do Docker ls, Docker container ls. Let's say I want to inspect that Redis container. What I can do, so I'm pretty sure it's named just Redis, but what I'll do is I can say sudo docker container inspect Redis. Is that going to work? Okay, let's do Redis 7-Alpine. Okay. Let's see, what did I call this thing? Oh, I think it's a Redis 1. I think is what it is. Okay, hang on. Nope. No such container. Okay, so I'm just trying to figure out what I actually named this container so it will pull up. Let's try it with the container ID. There we go. Okay. So what I did was I used the container ID instead of the name to inspect. And this is the kind of data that you're going to see here, which is this is the configuration data that Docker has for this particular container. So you can just see all kinds of stuff related to it. If it has any mount points, you'll see that. There might be some basic logging. You can see there's a host path here where it's saying var lib Docker containers, blah, blah, blah. So you can see like basically all the configuration details for these types of things. I can also run things like sudo docker stats. And what this does is it basically just shows you a live snapshot of the resource use, the running containers and the resource usage that's at play right now. So right now I've got 5 containers currently running, and you can see the percentage of CPU they're each using. And now what's really cool is you can see also the memory usage that's in play. And you can see these are each one of these is some kind of Linux environment, miniature Linux environment. And you can just look at the memory usage where 2 of these containers are only using, 23 and 47 megabytes. And the bottom 3 there are using, around 200. MySQL there at the bottom is using almost a gig, but that makes sense because that's a big database that I use for a lot of stuff. So it's got a lot of memory it does a lot of, MySQL does a lot of memory heavy operations. So the more data you put into a database like that, the more memory it uses, which makes sense. But still, I've got basically 5 different Ubuntu based virtual machines running on this MacBook, and it's barely using a gigabyte of memory, and it's barely using any CPU at all. So that's a pretty nice way to run these systems. So there's a lot more to that. You can investigate the Docker CLI yourself. There's just a ton of commands that you can run for Docker, but those are just an example of some. The other thing I'm going to show really quick is I have a virtual machine. I have a virtual disk that has that's an Ubuntu disk that has Docker installed on it. And I'm going to show you guys what that looks like if you bear with me just for a second. Okay. You guys should see my screen. You should see X-Ways pulled up. I know it's a little small. I tried to zoom in as far as I could, but this is the best I could get it. So what you're seeing here is this is a Linux virtual machine. This is a traditional VM image of a disk image of a traditional Linux Ubuntu virtual machine. And that virtual machine has it has Docker installed on it, and it has containers running. So I can navigate through. This is the file system here that you can see of that Linux virtual machine. And I can navigate down into the location where our Docker stuff is located, which is going to be under var, lib, and then Docker. So I can navigate into Docker, and just like I showed in the PowerPoint, you can see those locations. So we have our overlay 2, which is our location for the actual Docker images that get downloaded. We have an image folder here, which I don't know why they have overlay 2 and image, but that's just how they have it structured. Then we also have volumes, and then we even have containers. So if I drill down into containers, I can see there's at some point, there were at least 2 running containers when this VM snapshot was created. And then we have all this information here that we can look at. So there's a config file, there's a host name file, there's a host config. So all this really good stuff that we can look at to basically, if we don't have a live running Docker system, but we have an image of it, we can go through all this stuff and basically reverse engineer exactly what was going on with Docker in these containers. Like when they were running, how they were configured, what they were doing, what code, what images were they based on. There's all this stuff that we can look at just by examining these Docker locations to kind of go through stuff and do an examination. And so, and even you want to check for volumes, because volumes is where these containers will actually store data from running containers. Not all of them have volumes, but the ones that do, you really want to look at, because that's where you're going to get actual like user related data or potentially log data and that sort of thing. So we're just about out of time, so I'm going to pause there. Again, this isn't a comprehensive training session on Docker. This is just more to get you guys an intro to what Docker is, how it works, how to think about it in a forensic context. It's also to try to get you guys curious about Docker, so you'll do a little research on your own and kind of play with it yourself if you can. But this is a presentation I've done before. I usually take a little over an hour to do it, and we dig a little bit deeper into some stuff, but we only have about 45 minutes for these webinars. So doing just enough just to get you guys introduced to it and then get you guys curious about it. But I'll pause there and see if we have any Q&A to answer.
Alrighty, I don't see any Q&A yet. If anybody has questions, if you want to come on and ask your question live, go ahead and raise your hand and I'll give you permission to do that. Or if you prefer, you can just type your question in the chat and we'll get it answered for you. Okay, we do have a question from Greg in the chat. Are there any GUIs for managing Docker for those not good with the command line?
Yep. So you have Docker Desktop, which I mentioned earlier, which is the desktop client for managing Docker containers. And then there's also something called Portainer. So I'll type these in. So Docker Desktop and Portainer. But I'm not going to lie, when using Docker, you're going to have to get somewhat comfortable with command line. Because even at a basic level, because that's kind of how Docker works. So if you want to do anything, you know, in my opinion, I think if you want to do anything of value with Docker, you're gonna have to get comfortable with some command line stuff because it's a very technical system, and Docker Desktop and Portainer do give you some click-based utilities and things like that. But at the end of the day, you're going to want to get comfortable with the basic command line usage of Docker Desktop to really, effectively use it. And to be honest, you really only need to learn about 5 or 6 different command line commands. And that'll make your life a lot easier when you're using Docker because you'll be able to deploy and start stuff really quickly with Docker using command line as opposed to using a client like Docker Desktop or Portainer. I see another question here. Any DFI or Docker repos that you know about where people are sharing tools already made? Yeah, if you go to, I'm starting to see a lot more of this. The big one that I can think of right now is if you've ever been to the basic SANS forensic analysis courses, they always push out log to timeline and Plazo, or just building giant timelines for disk images. They have created a log to timeline Docker image that's on Docker Hub. So you can look at that image, and basically it makes it really nice because for the longest time, they didn't have a distribution for Windows, and you couldn't get an installer or a binary to run on Windows. But with Docker, you can now just run the Docker image version of it on Windows, which is really nice. And it's the same process. You just download the image, you just pull the image from Docker Hub, and then just using the Docker command, it uses the same command line interface. When using log to timeline, you're just using the Docker execution command as opposed to the log to timeline execution command. So it's really interesting. And I would just look around stuff like that and just keep an eye on the community and look. That's the one I could think of. I'd have to go look for other ones. I don't have anything on hand though, other than that one. Another question: if I'm interested in the more forensic application of Docker, like the inspect commands and more, when is a webinar for that? That's a good question, Duncan. I can plan to do another webinar where we can do like a part 2 of this, where I can do a deeper dive into the actual command line interface, and some of the, inspection processes that I would recommend if you're looking at a live running system. The downside from doing forensic analysis of a Docker system or Dockerized system is a lot of times, unless you're a DFIR, a lot of times you're probably just getting dead artifacts or you're getting a dead disk image that's not currently running. So those CLI commands may not be that useful, but there are ways you can extract containers and images, or you can look at the configuration and basically recreate the Docker environment locally on your test system and then use the CLI from there. But there are, in a forensic context, you may be limited to basically the fact that it's a dead box and the containers aren't currently running. Joseph is asking, if we do encounter a live system running Docker, is there any critical volatile data that would be lost by failing to capture RAM, or can most of the evidence be found in the forensic image? That's a good question. If you come across a live running system that has Docker that's running, you got to treat it you have to basically treat it like we would process a running server, right? So if you go back to your forensic training on how to handle a server that's running, you don't want to just unplug it, wrap it up, and take it back to the lab. You want to assess it and triage it to see what's running. Because if you have databases running, let's say that system is running Docker and it's got 3 or 4 databases like my Mac does right now, you want to make sure that it's shut down properly so that those databases don't get corrupted. If you just yank the plug on it while databases are running, you're going to get corrupted data. The way databases work is they do a lot of caching and they do a lot of lazy writes where changes live in memory before they're written to disk. So if you just go shut down a Docker container without doing it properly, you could actually corrupt a lot of data and lose it. You also want to make sure that Docker containers that are running are shut down properly, because shut down but not destroyed. That's an important concept, because if you have containers running in a Dockerized system that are storing data in a volume that's a default Docker volume, if you kill those containers, it can destroy any of that volume-based data that's there. So what you want to do is you don't want to destroy the containers. You just want to stop them from running. And there's a difference. You can stop containers without destroying them. This is where practicing with Docker is really important for this stuff. In terms of What exactly is stored in RAM? That's a great question. And I have not done that type of research. So I don't know exactly. I haven't done a RAM analysis of a system running containers to see what might be captured in memory. I imagine since Docker is piggybacking off the same RAM that's on the host system, I imagine you would get similar RAM artifacts from those containers. But I haven't done that analysis, so I don't really know too much what you can do there. Thomas is asking, do you have any experience with running forensic applications in Docker, e.g., apps for seizure from cloud? Um, try to parse what you're asking here. I think I understand what you're saying. I haven't run any. I don't know of any commercial applications that run in Docker other than obviously Monolith, but our tool isn't a forensic analysis tool. Um, but apps for seizure from cloud. I would imagine there's probably some smart folks out there that have written some stuff that they may have containerized it in a Docker image. But you can think of, if you see any open source Python scripts or anything like that out there, any script that you come across that you're running locally, you can convert that to a Docker container or a Docker image that can be containerized. So you could theoretically go out there and grab your own, either put together your own scripts or go out there and grab scripts that other people put together, and you can package those into Docker containers that you want. It's very simple. James is saying, it's not a question. I wanted to comment. I really appreciate this topic. I was pulled away from some of this presentation, but I'll review the recording. This topic is very relevant to an older case. Thank you so much. Okay, great. And James, that's a great comment. And just be aware, this is not a comprehensive training on Docker. This is really just an intro to get you guys introduced to the concept. This is a very deep concept. There's a lot of technical specifics to it. I recommend, if you've got a case that involves Docker, what I would recommend is don't just dive into Docker and start investigating it. I would really, really recommend you practice by getting a Docker deployment set up on either your forensic workstation or a test box, and then just start playing with. I think honestly, a good for forensic guys, just locate the log to timeline Docker image on Docker Hub, install that, and play around with that. Use the Docker image version of it to parse a disk image to get a log to timeline output. I think that's a very, very awesome way to get yourself acclimated to how Docker works. And it's a great way to do a little bit of self-training and get yourself used to how Docker, because you're going to have to go through the whole troubleshooting process of installing Docker, getting it running, downloading the image for Docker Hub, deploying the image as a container, and actually figuring out how to use it so that it will properly parse like a disk image, like an EM1 disk image or a raw disk image that you have, or even just a raw set of files, because you'll have to learn how to run the Docker commands and pass in the log to timeline command line entries to it. So I think a good practice session is just pulling up log to timeline and then running it. And then after running it, do your own forensic examination of that Docker system and seeing what you can figure out about, your instance of running log to timeline. Because honestly, you can go to any training you want on this Docker stuff, but until you just sit down and start doing it yourself and forcing yourself to apply Docker and actually use it, there's just no substitute for that. You're going to have to put the time in to just actually use Docker and, even investigate, how do I build my own images? How do I deploy Docker images to containers? How do I set up the configuration? You need to go through a few rounds of that to really fully have a really good grasp of how Docker works and how it can potentially work. And also, so you understand when you do a forensic examination of a Dockerized system, you have the context to understand what you're actually looking at forensically. When you look at config files or logs, or if you're reviewing the different images, containers, and volumes that are installed in that system, the best way to understand all that is to just deploy Docker yourself and start playing around with it. Okay. Looks like Duncan, other question. Doing app development, if I am testing software, what is a super useful tool that Docker, what is a super useful tool I wouldn't know is there? Oh, what is a super useful Docker has that I wouldn't know is there? I would say Docker Compose. If you're doing app development, I would say Docker Compose is a solid system, because it's not obvious when you're looking at, if you're just installing Docker and using Docker, the documents don't necessarily make it obvious that Docker Compose is a useful system. But Docker Compose is really useful because it allows you to just pre-configure a deployment for multiple containers that may orchestrate or work together. And then you could use that Docker deployment to just manage a more complex Docker environment. I would also recommend things like Portainer. I mentioned it earlier in the chat, but Portainer is really useful. It's an image unto itself that you deploy, but what Portainer is, it's an open source graphical user interface that launches as a web app. And it basically just lets you see through the interface and manage other Docker containers that are running in the same environment. It's very, very useful. We use it here for different things. It just makes it a little bit easier where you need to just, sometimes the command line is great for executing things, but it's not great for reviewing things or kind of just keeping tabs on things that you just want to see visually quickly. And that's where Portainer is really helpful. It just lets you see your environment graphically and easily navigate and do very simple things without having to lose context through the command line. Cool. I think that's it for questions.
Seems to be the case. Alrighty. In that case, thank you everybody for attending today. We really appreciate it. We'll get this recording out to you in the next day or so. And hope to see you in 2 weeks at the next one of these.
Cool. All right. Thanks, everybody.
Take care.